So iterators are cool, but they're not as cool as generators. Okay. I see someone's very thrilled with this. Okay. Generators are completely awesome. Okay. Generators were also introduced in Python 2.2, but you had to do the from future import generators or something like that. And they were made standard in 2.3. You can get information on generators in PEP 255. These things extend the idea of iterators. That's one thing that it does. But even better is it allows you to pause execution of a function, come back to it later, and resume right where you left off before. Okay? Yeah, okay. Now, if you're in C, you know that you can have, I think Java has this too, you can have these static variable inside your function so that if you call your function again, that variable has the same value every time you call that function, right? Does Java have that? It's a static variable where if you call a function or a method once, it saves the value of this variable, and then the next time you call this function again, it has that same value still instead of being reset. This idea, so that's nice, but that only preserves a value that you set in that function or method. What if I want to pause the execution of a function or method, and when I call it again, pick up right where it left off? So not only does it have all the data still, but it has the state still, right? So that is trickier to do, because that's what generators do. It allows you to pause the execution of a function, go back and resume where you left off. Okay. So anyway, so they do still extend from the idea of iterators. There's still a next method and all that stuff, and there's a new keyword called yield. All right, that allows you to do this. Syntactically, a generator is a function or method, but instead of just a return, you're also going to find at least one yield statement. Okay. What does it do? It allows you to save state across calls, right? So like I said, every single time you have a yield, that will kind of quote do a semi-return. And the next time you call that function again, it's going to pick up right below that yield statement. Okay? So you can merge iteration with state along with what I call resumable functions. Okay? Let's look at some examples. Okay? Here's a really stupid one. Yield 1, yield 2. So I'm trying to show you that you can yield different object types. First one is an integer, second one is a string. So I define this function that has yield in it, which means this is a generator. So now I have in my generator example, I call next on it, I get 1, I call next again, I get 2 with a string, then I call next again, and then raise it, the stop iteration exception is raised.
Actually, this is the best example I've seen to understand this, because when I first was introduced to it, I had a rough time conceptually understanding it.
Who's introducing it to you?
Oh, like
apparently it wasn't me.
No, it wasn't. But I mean, in other material prior to coming to this class, I had a hard time grasping it at first. But I'm looking at this and going, if I would have seen this example, I would have got it like that. In fact, if I can see it probably now if I put a print between the two yields. So the first next would stop at that first yield. When you did next again, it would do the print and then the second.
Yeah, cool.
So I would suggest just put another print in. Yeah. So so I didn't. This is a really good one. You know?
Thank you. That's why I'm teaching.
Yeah. You said it was a stupid
I'm trying to
one.
make a living, okay?
You said it was stupid, but this is a really good one. You know, example to understand the concept.
I have to say, I shamelessly copied this from the article I wrote for Linux Journal. So I actually did this slide after I did that article, but in that moment of euphoria discovering generators, I had to, how can I boil this down to the most basic thing?
You got it. Yeah.
It was hard for me, and I had to learn it too, right? And see, how can I, when I finally got it, I go, okay, this has got to be this is the dumbest one, but it's the one that's the most clear. Now that you've done the dumb one, now you can look at something nice. This is exactly the same as my iterator, but it stops. Okay? So, I should actually use rand range instead of rand int. I'm sorry, I'm using rand int. Rand range is preferred over rand int because everybody knows the syntax for range, but now if I have to learn rand int, I have to recall that it's inclusive instead of exclusive. So people say just use rand range because then it's the same syntax as range, up to but not including the j. Okay. So anyway, so I have a random generator here. While my list is greater than 0, I'm actually going to remove the item that I get rid of. And which one do I get rid of? A random one between 0 and the length of my sequence minus 1. So that's just pick a random element in my sequence, pop it off, and so the next time I come back to, I only have the remaining ones. Okay. So this is the same thing as the other iterator, except I'm only going to get them once, one at a time. Okay. The difference between this one and the other one, like I said there, is that each item is consumed rather than going through forever.
So it essentially makes